Okay, you're welcome back. Now we want to talk about physical and chemical changes. Okay, referring to physical and chemical changes, we've already identified what physical properties are and also what chemical properties are. So, what are physical changes? These are changes that has to do with the physical nature of a substance without changing its identity. And what are chemical changes? Well, that implies that this involves the change in identity of the substance. Thus, when matter changes, its identity is a chemical change. But if matter just changes its shape or changes its let me say, it just alters the nature, the way it looks like. For instance, ice that used to look like that used to be solid becomes liquid, and that's just a physical change. But if it stops being water and becomes something else, then definitely it's a chemical change. Now, it will be helpful if we identify the major differences between physical and chemical changes. Now, talking about physical changes, well, one thing I need us to understand is since the identity is not altered, it means this one can be reversible. That it can be easily reversible. Easily reversible. Sorry, reversible. But in chemical changes, the identity of the substance is altered, is changed. Hence, this one is not easily reversible. It's not easily reversible. Now, in that on that notion, we can actually say since identity is not affected, we can actually say this no new substance is formed. No new substance. Then looking at chemical changes, the identity now is changed, which means it's no longer what it used to be. We can now say that new substances are formed. New substances formed. So in physical changes, no new substance is formed, but in chemical changes, new substances are formed. Okay, now another thing I need us to understand is this. No new substance formed, it means no change in mass. No change in mass. Now some of you might be wondering, what exactly is mass? Well, this is a quantity of stuff or quantity of matter that makes up an object. Okay, let me scale it up a bit. If I have chalk, now the chalk is made up of tiny powders that compile up to that chalk. Now those tiny powders are not the atoms, okay? But for the sake of this explanation, let's assume that that's the unit of that chalk. So the quantity of tiny powders that make up the chalk stick, that is what we refer to as a mass. Okay, and mass is usually measured in kilograms. Okay, so um, in this case, for chemical changes, since if a chalk undergoes physical change, it's no longer chalk, it stops being chalk, which means if it used to have chalk particles, those tiny powders, if it changes to a new substance, it will no longer have those chalk particles. Automatically, the mass will change. So, chemical changes lead to change in mass. Now, to change the identity of something is not easy. Okay? So, while physical changes requires generally low heat. Okay? One thing we observe about chemical changes, because we are changing the identity of something, it requires large heat. It requires large heat change. Okay, so these are some of the fundamental differences between physical changes and chemical changes. Okay, so can we mention some examples of physical changes? So talking about physical changes, we already know, for example, melting of candle wax. Melting of wax. So when you look at candle wax, when you heat it, It melts as a candle burns, but when it cools, it solidifies, becoming what it used to be. It remains what it is. Okay, so whether the wax is in solid form or in liquid form, its identity doesn't change, which makes it a physical change. Okay, another example we can have is dissolution of salts. Okay, when we dissolve salts, dissolution, sorry, dissolution of salt. Now, salt crystals, don't forget, even though they're in small particles, they're actually solids. If I dissolve it in water, it tends to become liquid. But when I boil the water and remove the water, I get back my solid crystal salt, which means no major change occurred. The identity of the salt didn't change. Okay, so it's a physical change. Then we also have um, sublimation. Sublimation of substances. Example, ammonium chloride. Okay, so what is sublimation? This is a process whereby substances change from solid directly to gas without changing to an intervening liquid medium. Okay, so substances that sublimate, when you cool them off, they still come back to solid state, which means nothing new. They didn't change. They only changed state. They didn't change identity. So it's still a physical change. Also, we have a magnetization of iron. Magnetization and demagnetization. Demagnetization. So all of these are what? Physical changes. So iron, in the presence of heat, when heated, can lose its magnetic qualities. Okay. Also, when cooled, can also regain its what magnetic quality. The identity of the iron didn't change. Okay. The identity of the magnet didn't change. Okay. Magnetization of magnets or iron. So these are some of the examples of what physical changes. Identity of the substance didn't change. It might change shape, it might change state, but it doesn't change its identity. So all of these are what physical changes. Okay, now we've talked about physical changes and examples. What about examples of chemical changes? Now, referring to chemical changes, okay, chemical changes. This one will involve alteration or change in the nature of a substance. Okay, so we've already talked about burning of something like burning charcoal. So when you burn charcoal, you actually change the identity of the charcoal. Okay, it's now changed to carbon dioxide, heat and light, and you're left with barely ashes. Okay, so you see that that's a chemical change because it's not easily reversible. Okay, then we also have dissolution of alkaline metals. Okay, we'll go into the details of alkaline metals later. Okay, so metals like sodium, metals like potassium. Okay, so these substances, when they actually combine with water, H2O, you don't just say, okay, I dissolve them in water, let me boil them and get back my sodium. No, sodium combining with water, we actually, like when sodium combines with H2O, okay, we realize that it actually gives us sodium hydroxide. Okay, so this gives us sodium hydroxide. So in this case, we can be having I think that will be 2 moles of sodium. I think